This lesson is a tour of network devices, and there are enough of them that memorizing 9 separate definitions is a poor strategy. Under pressure, they blur into each other. So here is an organizing question you can apply to every device on this page. What does it decide? A device that decides nothing simply passes everything on. A device that decides based on a MAC address works within one network. A device that decides based on an IP address works between networks. And a device that decides whether something is allowed through at all is a security device. Once you sort them that way, the differences that examiners test stop being arbitrary. Let us go through them. The network interface card, the NIC, is the component that allows a computer to connect to a network at all. It is internal hardware, these days built into the motherboard rather than being a separate card, and it converts the computer's data into signals suitable for the transmission medium and back again. The point the syllabus cares about is that the NIC contains the MAC address, the unique physical identifier of that device, assigned by the manufacturer and fixed in the hardware. That address is the subject of the next lesson, so for now just fix the association. MAC addresses live in the NIC. Now the comparison that comes up most often, hub against switch. A hub decides nothing. When data arrives, it sends a copy to every device connected to it, and each device inspects the packet to see whether it was the intended recipient. Everything else discards it. That produces 2 problems, and questions want both. It is inefficient because the network carries a great deal of traffic that nobody wanted, and collisions become likely as the network grows. And it is insecure because every device receives a copy of data intended for someone else, which anyone can capture. A switch does decide. It reads the destination MAC address on each frame and forwards it only to the device that address belongs to. Less traffic, fewer collisions, and other devices never see data that was not meant for them. So a switch is not a faster hub. It is a hub that makes a decision, and the decision is based on the MAC address. That last detail is the mark. The router is the traffic controller, and it connects different networks together, your home network to your internet service provider, and through them to the rest of the internet. It decides too, but on a different basis. It uses IP addresses, not MAC addresses, and it chooses which route a packet should take to move it towards its destination efficiently. That is the distinction to hold. A switch directs traffic within a network using MAC addresses. A router directs traffic between networks using IP addresses. Both make decisions. They use different information and operate at different scopes. This is also the device that ties back to packet switching in topic 2. The routers deciding independently for every packet, which is why packets can arrive out of order, are exactly these. The modem gets its name from what it does, modulator, demodulator. It converts the digital signals a computer produces into analog signals that can travel over telephone lines or cable, and converts incoming analog signals back into digital for the computer. That is a conversion, not a decision. The modem does not choose where anything goes. Note the connection to topic 1. The reason a modem is needed at all is the analog-digital divide we met with sensors and ADCs. A computer is digital. Some transmission media carry analog signals. Something has to translate between them. Modern fiber and cable connections have changed the details, but the exam answer remains digital to analog and back. 2 smaller devices. A bridge connects 2 separate local area networks that use the same protocol so that they function as a single network. The phrase same protocol matters because it is precisely what distinguishes a bridge from a gateway in a moment. A wireless access point, a WAP, provides a wireless signal, Wi-Fi, allowing mobile devices to join a network that is otherwise wired. In most homes, the router, the modem, the switch, and the wireless access point are all inside one physical box supplied by the internet provider, which is why these distinctions feel artificial. They are still 4 different functions, and an exam question will ask about the function rather than the box. A gateway is a node that connects 2 networks which use different protocols. It translates the data so that the receiving network can understand it. Put the bridge and the gateway side by side, and the distinction is clean. A bridge joins two networks that already speak the same language, so nothing needs translating. A gateway joins two that do not, so translation is its entire purpose. If a question mentions different protocols, the answer is a gateway. If it says the same protocol, it is a bridge. That single word in the question is doing the work. Now, the two devices that decide whether something is allowed. A firewall monitors incoming and outgoing traffic and blocks unauthorized access according to a set of rules. It can be hardware, software, or both. It sits between a trusted network and an untrusted one and examines traffic against criteria such as source address, destination, and port, permitting or blocking accordingly. A proxy server acts as an intermediary between a user and the internet. Requests go to the proxy, and the proxy makes them on the user's behalf. That gives it two useful properties. It can cache frequently visited pages so that a page requested by many people in an organization is served from the local copy rather than fetched again, which is faster and reduces bandwidth. And it hides the user's real IP address, since the website sees the proxy's address instead. It can also filter content, blocking access to particular sites. Both are security devices, but keep their jobs apart. A firewall decides what may pass in and out. A proxy makes requests on your behalf and can cache and hide. Finally, the media that link this hardware together, which we met in topic 2.1 and are worth reconnecting here. Ethernet copper cable carries electrical pulses. It is good for local area networks, but limited to about 100 meters before the signal degrades. Fiber optic cable carries pulses of light. It offers very high bandwidth over long distances without significant loss, which is why it is used for network backbones and undersea links rather than for connecting a printer. And radio waves carry Wi-Fi and Bluetooth, which is unguided transmission. The signal is not confined to a cable, which is what gives it mobility and also what makes it easier to intercept. Guided media, meaning cables, are faster and more secure. Unguided media are convenient and mobile. That trade-off is the one to state. 4 things to take away, and they are the confusions that cost marks. First, hub against switch. The hub sends data to every device. The switch sends it only to the intended recipient using the destination MAC address. Say MAC address explicitly. Second, switch against router. The switch works within one network using MAC addresses. The router works between networks using IP addresses. Third, bridge against gateway. Same protocol means bridge, different protocols means gateway. And fourth, firewall against proxy. The firewall filters traffic against rules. The proxy makes requests on your behalf, caching pages and hiding your IP address. And if a device slips your mind in the exam, fall back on the question we started with. What does this device decide, and what information does it decide with? For most of these, that reconstructs the answer.